Now let's talk about the basics of heat movement. We know that heat always goes from warmer areas to colder areas. Okay? Heat always goes from warmer to colder. The sun always heats the earth. Okay? Second, the greater the temperature difference, the faster heat flows. And third, temperature gradients cause air movement, and air contains moisture. So that has an impact on building durability. So when we look at this thermographic image here, the brighter colors are the areas of greatest heat loss. We can see here, for example, that there's no insulation in the wall system here. So that means we have what? Greater heat flow. Greater heat flow means greater energy costs. Now let's not confuse heat with temperature. For example, if we have 10 gallons of water at 50 degrees Fahrenheit, that's going to contain quite a bit more heat, 10 times more heat than 1 gallon of water at 50 degrees Fahrenheit. This has more thermal mass, so it has more heat capacity. This is why, for example, in solar homes, that they tend to put tile floor downs or concrete floors. That way, the energy from the sun comes through the glass, heats up that thermal mass, and then, of course, it re-radiates throughout the structure and helps reduce the heating costs. So let's not confuse heat with temperature. Okay. Second, as I mentioned earlier, the greater the temperature difference, the faster heat flows. Now this is important. If I go outside on a day when it's 69 degrees outside, do I feel uncomfortable fairly quickly? No. There's not much heat transfer. If it's 70 degrees inside and 70 degrees outside, do I have any heat transfer? No. But if it's 70 degrees inside and it's 0 degrees outside, we have what? A big temperature difference, which means a greater temperature gradient, which means more heat transfer. So I get uncomfortable a lot quicker if there's a greater temperature difference. So temperature difference has a big impact on comfort. There are three basic factors that affect heat transfer, and that will help us, if we master this, that helps us understand and evaluate different insulation systems, for example, and different energy systems that we might put in the structure. First of all, as I mentioned, temperature difference is a factor. In other words, I have more heat loss if it's colder outside than I do if it's warmer, for example. The time over which the transfer occurs. So, for example, if I go outside and it's 0 degrees outside and I'm outside for an hour, I feel a lot worse than if I was outside for only 15 minutes. Because the greater the time, the greater the transfer of heat. And then, of course, the area over which the transfer occurs. In other words, if I have a bigger house, guess what? It takes more energy to heat a bigger house because I have a greater what? Heat transfer surface area. When we look at air conditioning systems today, for example, you might notice that the air conditioning condensing coils today are a lot larger than the coils of yesteryear. And the reason for that is they have bigger heat transfer surfaces, and that's how they're more efficient. They have a better ability to transfer heat. So in thinking about the three factors that affect heat transfer, one is the temperature difference over which the transfer occurs. Two, it's the time over which that heat transfer occurs. And three, the area over which heat transfer occurs. This is exemplified by this chart. If we look at 100 BTUs for 1 hour, it's very linear. We come over here to 3 hours, we have 300 BTUs per hour. If we look at area, it's the same thing. If we have 10 BTUs per hour lost out of 1 square foot, that means for 4 square feet, we have 40 BTUs per hour. So the greater the area, the greater the heat transfer. Now, when we think about understanding how buildings work and how insulation works and air barriers work, it's important to understand some basic concepts of heat transfer. And there's three basic ways that heat is transferred. One is conduction, one is convection, and one is radiation. If we look at this example here of this potbelly stove here, we know that if that metal gets hot and I go up and touch the metal, what do I feel? I feel maybe I'll get burned, right? Because I have heat transfer. The heat is radiating, or heat is transferring from one molecule to the next from the hot metal to my hand. That's heat transfer by conduction. Now, if my hand is burnt and I wave my hand through the air like this, why do I do that? That's because I'm trying to what? Cool my hand off, which means the air is cooler than my hand, and so the heat is trying to leave my hand to the air around it. That's heat transfer by convection. And heat transfer by radiation is a little bit more complicated in the sense that it's not a linear relationship and it is line of sight. So for example, if I'm in the direct path of the heat radiating off of this stove, for example, I will feel that radiant heat. Now, heat transfer by radiation is nonlinear. As a matter of fact, heat radiates at like T to the 4th power. That's why when you go outside on a hot day, you immediately feel the sun strike you. When you step in the shade, you feel cooler. When you step back in the sun again, you immediately feel that heat transfer. That's because radiant energy happens very, very quickly. Now, if I take a piece of aluminum foil, for example, and I put it in between myself and the heat source, what does that do? That tends to reflect that heat back, and we'll talk more later about radiant heat transfer and how that impacts comfort and a whole variety of issues. When we think about how we deal with radiant issues, for example, a good example of that is low-E glass. It reflects as much as 60 to 70% of the sun's heat, for example, from entering the structure. So radiant transfer is important also in terms of comfort. So conduction, convection, radiation.